So the goal of this video is to help you not only do these exponent ST math levels, but also think about the idea of preserving equivalency, which is a key mathematical idea, is the idea of being able to have two things look different, but have the same value. So you're in this third circle today, and I'm going to skip ahead to the last one so you can kind of see where you're going. So what we're trying to do is take this expression and make it equivalent to this visual. And this is going to help you visualize how big these exponential expressions are and to get a sense of it. So this is a pretty big number. There's a lot of these little circles. So how do we get there? Well, we started with 1, right? And then we multiplied by 4 because there's 4 in this little group here. So I know that's my base. Now, how many times did I multiply by 4? Well, once to get this, twice to get this shape, 3 times to get this, and then 4 times to get this because it just repeats itself. It's like a tessellation. So I multiplied by 4. One of these multiplied by 4 once, twice, 3 times, 4 times. So what that means is I had 4 to the 4th. Now, what we talked about today is some exponential trickery. How can you kind of play around with these exponents and keep the same value? Well, let's break down what 4 to the 4th means. You can't be trickery, can't have trickery unless you understand what's going on underneath. So 4 times 4 times 4 times 4. That's what 4 to the 4th means, right? Well, what are some relationships that go with 4? Well, first thing that comes to mind would be 16, right? I know that 16 is the same thing as 4 squared. Well, if I know that, if you think about it, right, 4 times 4 is 16, right? So there's 116. And then this 4 times 4 is 16. So I can say 4 to the 4th is the same thing as 16 squared, right? Because it takes 4 factors of 4 to get that big value, or it takes 2 factors of 16. So 4 to the 4th and 16 squared are the same thing. I have different bases, but they're the same value. There's a little exponential trickery for you. And it's the idea of preserving equivalency. I changed the base, but because I changed the exponent in the right proportion, I have a equivalent expression. Let's look at another one here. How about this one? Well, it looks like I started with 1. I multiplied by 2 once, multiplied by 2 again, multiplied by 2 again, and then multiplied by 2 again. I doubled everything. So I started with 1 times 2, that's twice, times 2, that's 3 times, times 2 again, that's 4 times. So 2 is my base, and 4 happens to be my exponent again. So let's put that one in there. How about 2 to the 4th? Well, 2 to the 4th is just 2 times 2 times 2 times 2. All right. Well, what are some relationships? Well, when I see 2, I know 2 is this 2 squared is the same thing as 4. So I could say 4 is the same thing as 2 squared, right? Well, in the same way as this time, this last one, well, this 2 times 2 is 4. And this 2 times 2 is 4. So 4 times 4 I know is 4 squared. So 2 to the 4th is the same thing as 4 squared, right? I know this is 16, right? And 2 times 2 times 2 times 2 is 16. And if you can see how all I did was take these two 2's and made it a 4, and these two 2's and made it a 4, and all of a sudden I have a different but the same value. Let's look at another one. All right, this one looks like I start with 3. 3, and then I multiply, I start with 1, and I multiply by 3 once, twice, 3 times, and 4 times again. Why does it always 4? All right. So what does that look like? Well, this time it's 3 to the 4th. Well, I know that's 3 times 3 times 3 times 3. It's a pretty big number. It's a lot bigger than 2 to the 4th, right? 2 to the 4th is only 16. 3 to the 4th is a lot, as we saw in that picture on ST Math. Well, what's a relationship? All right, well, let's see. I know 3 times 3 is 9. So I know 3 times 3, or 3 squared, is the same thing as 9. Well, 3 times 3 is 9. And this 3 times 3 is 9. So 4 3's multiplied together is the same thing as 2 9's multiplied together, which would be 9 squared. So now what I have is another equivalent expression. 3 to the 4th is the same thing as 9 squared. This is going to be very useful as we start playing around and having to do operations with exponents and solving equations with exponents. The more we can change the base, just like changing a fraction to a decimal, changing the way it looks, but keeping its equivalence is going to be helpful. Let's look at maybe one or two more. Let's see here. All right, here's a 2 guy. All right, so start at 1, I multiplied by 2, then I doubled it again, doubled it again, doubled it again, and doubled it again. So I doubled it once, twice, 3 times, 4 times, 5 times. This is 2 to the 5th. Now this is an important one because you're going to notice we came up with a little problem here. 2 to the 5th, we know, is 2 times 2 times 2 times 2 times 2. Well, I know that 4 is the same thing as 2 squared. The problem is these two and these two, I make a 4 times a 4, but then I have this extra 2, right? It doesn't have any guy to go with, so it can't become a 4. So I can say 4 squared, get rid of this, times 2, but that's a little messy, right? It doesn't work when that exponent's odd like that and I'm trying to change it. So this does work. 4 squared times 2 is the same thing as 2 to the 5th, but it's not nice and neat with one base and one exponent like these other three. So that happens, right? So you got to, again, pay attention that sometimes this trick really works, but sometimes it doesn't. So let's see if we can get one more good one. There's one, the ST Math. Sometimes they don't like to do what I want to do. All right, this might be a good one. All right, so here, 1 times 4 is going to give me that guy. And then I did that once, twice, 3 times. Well, there's another odd exponent. So let's see what might happen with this guy. All right, so this is 4 cubed. And if I did that 4 times 4 times 4, well, I know, again, just like up here, 16 is the same thing as 4 squared, so I can use that 16 trick, but again, I can't make 2 16. I can make 1 16, but then I still have that extra 4, right? So there's 3 4s in there, right? 4 times 4 times 4, but I basically just have to write 16 to the first, right? There's only 1 16 times 4, or 4 to the first. All right. So this one, again, that odd one didn't work. But wait a minute. Wait 1 minute. Last one. Let me show you a little something. Some of you might have noticed it. I think there might be another relationship with 4. And I believe there is, because I know this is still 4 times 4 times 4. 4 times 4 times 4. I know that 4 is the same thing as 2 squared. So I could actually write this 4 as 2 times 2 times this 4, which is 2 times 2, times this 4, which is 2 times 2. Now, how many 4s do I have, or how many 2s do I have? 1, 2, 3, 4, 5, 6. So I can actually do this and say, I can go the other way and make it like more factors of 2. Like up here, I made 2 factors of 16, but I could actually make factors of 2 here as well. Let's If you're interested, let's try this one more time. Let's copy these guys. Let's look at this one. Let's do that 4 to the 4th one. Maybe you can figure out what it's going to be. 4 to the 4th is 4 times 4 times 4 times 4. And we already changed it to a base of 16. Let's change it to a base of 2 like this one. Well, if 4 is 2 squared, how many 2's are in this one? There's 2 here. 2 times 2. And then there's 2 here. That's another 2 times 2. And then there's another 2 here. Times 2 times 2. And then there's another 2 here. So how many 2's is that? 1, 2, 3, 4, 5, 6, 7, 8, which makes sense. There's two 2's in this 4. There's 2 2's in this 4, and so on. So I have 4 to the 4th is the same thing as 2 to the 8th. 4 to the 4th is the same thing as 16 squared. So this guy, and this guy all mean the same thing. They're all equivalent. All right. 4 squared is the same thing as 2 to the 4th. 3 to the 4th, the same thing as 9 squared. It doesn't work for every single one nice and neat, but this is the idea, exponential trickery. The more you understand exponents, the more you can do with it. And that's anything in life, right? The more you understand about any topic, the more you can play around with it. The more you understand about language, the more you can have play around with it and write great poems and great stories. The more you understand mathematics, the better you can understand and play around with graphs and tables and charts and not be tricked by people that are trying to trick you with wrong tables and graphs and charts. Just the more you understand about any topic, the more you can do with it. Music, that's a great example, right? Jazz, right? If you can know music and you can kind of play around with it and play great jazz. Talk to Mr. Carroll about that one. Hashtag Mr. Carroll. So play your SD math, and great job.